So the goal for this day one is to understand what row echelon form actually is and what it's used for and how we get there. Okay, so what I'm going to do is I'm going to give you a system right now. I'm going to show you a system. It's going to have 3 variables in it, and there are going to be 3 equations in it. So the system I'm going to show you, I'll use a black pen for this, is going to be this. It's going to be x minus 2y plus 3z equals 9. And then the next one is going to be y plus 3z is equal to 5. And then finally, z is equal to 2. Okay, so what you see right there on the left-hand side, I need to clap. what you see is a system of linear equations. They're all linear, right? And notice that there are 3 variables. There's an x variable, a y variable, and a z variable, okay? This system right now is in row echelon form. Okay, so let's talk about the things that are important about it being in row echelon form. Okay, the first thing is that do you notice that there is sort of this staircase pattern here that goes all the way down? See that staircase pattern? Okay, so the staircase pattern is part of the row echelon form. So we'll write that in there. Okay, so staircase pattern. Okay, the next thing that we want to notice about something that's in row echelon form is that all of my columns are lined up, right? So this is kind of the x column, this is kind of the y column, and this is the z column, right? So columns go up and down, and there are no x's below the first x in that first column. Notice there's no y's in that last underneath that second one, and then finally there's a z in that last one. So we have the x, y, and z columns all lined up. And then if we go the other way, these right here, these are called our rows. So left to right. So we have, this is our column 1. So column 1, this is column number 2, this is column number 3. All right? And then I have these parts, this is row 1, this is row 2, and this is row 3. So I'm kind of breaking up into rows and columns. Okay? The other thing that you want to notice is that what is the number, or what are the leading coefficients in all of my variables? What are they? 1. There's a 1 there, and a 1 there, okay? So what we want to do is we want to get a 1 in the leading coefficients. This is our goal. A 1 is our leading coefficient. Okay, so we want 1s in the leading coefficient. We want the staircase pattern. We want our columns to all line up. And we want our rows to all line up. We have row 1, 2, 3, column 1, 2, and 3. Okay, what do you think so far? Is it pretty easy so far? Yeah. The goal is always going to be to get our system to look like this. So when we say put this system into row echelon form, this is the form that we want. We want to have that staircase pattern. We want to have leading coefficients of 1, and we want to have zeros underneath our variables. What I mean by that is like there's a 0 here, there's a 0 there, then there's a 0 there for that one. Okay, that's what we're looking for, zeros in those spots. So I realize that's all kind of messy, but hopefully that comes together for you. Okay, so I'm going to rewrite this down here because I'm going to show you what the point of it is. So if I have an x minus 2y plus a 3z equals 9, and if I have a y plus 3z is equal to 5, and then I have z is equal to 2. Okay, so the reason that we want to get our systems into row echelon form is because once we have one variable solved for, we can then use something that's called back substitution to solve for the other 2 variables. So remember, the answer is going to be x, comma, y, comma, z, because there are 3 variables in this. So here is going to be the answer over here. Okay, and right now we know that z is a value of 2. So that one's pretty easy. We got that one down. We got to get x and y. Now, if z is 2, we can use something called back substitution to get y. So in this case, we know that y plus 3 times 2 is equal to 5 from row 2. So that means that y plus 6 got to be 5. So that means that y has got to be a negative 1. So y then is negative 1. Good. Now that I know what y is negative 1, we can use back substitution again and go up to row 1 and solve for that one. So I would have x minus 2 times y, which is negative 1, plus 3 times z, which is 2, has to equal 9, right? So let me move over there for that. So I'm getting x plus 2 plus 6 equals 9. So that means that x plus, is that, oh, that's 8 equals 9. Yikes. So therefore x has to be what, everybody?
1.
Okay, so there we go. So now I have an answer of 1, -1, and 2. And I got it because this whole thing was in row echelon form, and we used back substitution to get it. Okay, so there's a technique called Gaussian elimination, and you use Gaussian elimination. So you use Gaussian elimination, GE, to put a system into row echelon form, REF. So that's what you use it for. Gaussian elimination is used to put a system into row echelon form. Okay, so that's what we have it for. That's the technique. But there are a couple of rules that go with Gaussian elimination. So I'm going to tell you that there are 3 rules, okay? And these rules are called row operations. All right, they are not called column operations, so take that into consideration. They're called row operations. So that means that you can only apply these 3 rules to a row and not a column.
The rows are sideways.
The rows go left and right. Yeah, rows go left and right, columns go up and down, okay? So the first rule is this, is you are allowed to switch any 2 rows. So if you want the third one to be the first row or the second one to be the third row, whatever you want, you can switch them, okay? You are allowed to do that. The second rule is you are allowed to multiply any row you want, any row, by a non-zero constant. Non-zero constant. So you're not allowed to say, I'm going to go ahead and multiply row 3 by 0 and then eliminate it. That is unfortunate. You're not allowed to do that. But you can multiply row 3 by, say, 2, 5, whatever you want, right? As long as it's a non-zero constant. And then number 3 is kind of a hybrid of the first 2 rules. You are allowed to do this. You're allowed to add, it says add, a multiple of a row to another row. Okay, so these are our 3 rules that we are allowed to use for Gaussian elimination, and they apply to rows only. You can switch any 2 rows, you can multiply any row by a non-zero constant, or you can add a multiple of a row to another row, or you can use any variation of, or any combination of all 3 at once. Okay? So, let me give you, that was box 2, here's box 3. Let me give you 2 examples here. Okay, I'm going to do example number 1, just kind of a basic one, and then I'll do example number 2. Okay? So example number 1 is going to say this. We're going to use Gaussian elimination to get this 3x minus 2y equals -1, and then x minus y equals 0. We're going to use Gaussian elimination with back substitution to solve this system. Now I'm going to go ahead and say that that's not the most efficient way to solve this system, but I'm trying to get us in the mindset of looking at how to get something in row echelon form, okay? So right off the bat, is this in row echelon form, yes or no? No, it's not. Okay, so what's the first thing that you do want? What would you want to get?
Coefficients to be 1.
You want to get a 1 in this location right here. Okay, so how do you do that? What could you do?
Divide by 1/3.
So you can't divide.
Multiply by 1/3.
You can multiply by a third, or you can take Paige's idea and just do what? Just switch the 2 rows. So let's do that. Okay, so we're gonna have something that looks like this. So we'll have x minus y equals 0, and 3x minus 2y equals -1. There we go. Now we have a 1 in that spot. Now we can move up. Okay, all I did was switch 2 rows. Okay, now what do I want? I want to get a 0 in what location? I want to get a 0 there. So how do I do it?
Multiply the top one by -3.
Yes, very good. If that top row, if that x was a -3x, and then I added it to row 2, wouldn't it go away? It sure would. So here is how you do this. Here's the notation, right? So over to the right, you're going to draw a line. And in that line, you're going to give me the roadmap, or what I call a roadmap, of what it is that you're going to do. And this is the operation we're going to do. we're going to do negative 3 times row 1. And then we're going to add that to row number 2. And notice that my roadmap here, my direction is lined up directly with the line that I'm going to replace, the row I'm going to replace. You guys see that? Okay, so that's going to be my map that tells me what to do. And I'm going to rewrite everything right below it. Am I doing anything to row number 1, you guys? No, so that stays the same. So I'm going to have x minus y equals 0. But row number 2 is now going to change, okay? So here's what the deal. I'm going to take negative 3 times x. How much is that? Negative 3x plus the 3x, how much is that? 0. And that goes right here.
But why? Why are you allowed to do that?
Because what I'm doing is I'm multiplying a row 1 by negative 3, and then I'm adding that to row number 2.
But you do it to the whole thing, so it remains.
Right, do it to the whole row.
real, like,
Yes.
You have to like change the negative.
We got to change everything, yeah. So let's do the next one, okay? What's negative 3 times a negative y, everybody? Positive 3y. What's 3y minus 2y? Y, 1y, okay? So that's plus y, positive y, good. Okay, then, what is negative 3 times 0? 0 plus a negative 1? Negative 1, all right? Okay, now, is my new system in row echelon form? Yes, it certainly is. So check this out. I have my staircase pattern going on. I have 1s in my leading coefficients, right? I am all good to go. So therefore, I can now use back substitution and get my answer. It says that x minus negative 1 has to be 0, so x plus 1 has to be 0, so x must be negative 1. Therefore, my answer is negative 1, comma, negative 1. Now, I'll admit that's not a very efficient way to solve this particular system, right? We could have just used substitution right off the bat and got the answer. But I wanted us to practice, get us in the mindset of thinking in row echelon form, okay? Now let's do the big example. Are you ready for it? Yeah, I love your enthusiasm, I gotta say. I love it. I'm all about it.
Is this our last?
This is it, yep, example number 2. Here we go, it's the big kahuna right here. You ready? Okay. Okay, this is a pretty big system here, okay? Okay, so this is not in row echelon form, right? We're going to put it in row echelon form using Gaussian elimination with those 3 rules that we had before, okay? So now we have a 1 in the leading coefficient for our x. That's a good thing. So what do we now want to get?
You have 1 for negative x.
We want a 0 here and we want a 0 here, right? That's what we want, okay? So how are we going to get it? Okay, we're trying to get a 0 where that in row number 2 in the first position. So can't we just add row 1 plus row 2? Yeah, but I can say 1 times row 1 plus row 2, right? There we go. Okay, so let's go ahead and do that. Am I doing anything to the top row? No. So I write that down. X minus 2y plus 3z equals 9. I'm doing nothing to the top row. Okay, let's do this now. Negative 1. So I'm basically adding row 1 and row 2 together, right? So I'm going to get 0x. I'm going to get 1y, so plus y. I'm going to get plus 3z equals what? What's that?
Negative 4.
5. Very good. Okay, equals 5. All right? Because I added row 1 and row 2 together. Okay, now, what do I want in row number 3 in the first position? I want to get a 0, right? So how could I get rid of that? What could I do? Yeah, let's do negative 2 times row 1. I'm going to add to that row 3. All right? And so notice you're telling me what you're doing on the right-hand side there with that notation so that we can then follow it into the line below it, okay? So we're going to go negative 2 times row 1 plus, so that's going to give me a 0 here. It's designed to give me a 0, right? Okay, good. So let's hear negative 2 times a negative 2y would be a positive 4y. Positive 4y minus 5y is how much? Negative y. Good. Okay. Negative 2 times 3z. How much is that? Negative 6z plus a 5z. How much is that?
Negative 1.
Minus z equals, okay, negative 2 times 9. How much is that? Negative 18 plus 17 is negative 1, right? Okay, good. Now we're down to here. Now I have a new system. So I can go ahead and get rid of all of those because I don't need them anymore, right? All right, good. So what we've done is we've created an equivalent system and we're getting it into row echelon form. Okay, good. So I have my 1 in front of my x. I have my 1 in front of my y. What do I want to do now? Get rid of that negative y. Good. So what's my roadmap going to be? What am I going to do?
Multiply negative 1 by row 3 plus row 3.
Yeah, there you go. So we're going to do 1 times row 1 plus row 3. Very good. So am I doing anything to the top row, you guys? No. X minus 2y plus 3z equals 9. Am I doing anything to the second row? No. Y plus 3z equals 5. Okay, great. Now, add the second and the third row together. What do I get?
0.
I get a 0 there, right? Okay, 3z plus a negative z, how much is that? Yep, so I'm going to have plus 2z equals what? Equals 4. Very good. Okay, I no longer need this one now. Okay, we're getting there, right? There's one more step to do. What would it be?
Multiply by
Yeah,
1.
so 1/2 row 3. Awesome, you guys totally get this, okay? So therefore, here's what we have. X minus 2y plus 3z equals 9. Y plus 3z equals 5. And z equals what? 2. Ladies and gentlemen, this is row echelon form. And check this out. If you go look back up to the very first one, it's the very first one that we did, okay? So we've come full circle in this lesson. The reason I did that one, you guys, is because then you have the notes on how to solve it, right? You would then, from row echelon form, you could use back substitution to solve it.